Hi students, this is Miss Cave with a lesson on indirect measurement, and the SOL for this, for Virginia, the Virginia SOL is 7.5, and we're using similar figures, what we learned about similar figures, to answer practical problems or real life problems. Today we're going to be looking at how to find the missing side length of two similar shapes or a similar shape, and then we're going to apply it to an indirect measurement problem. So first of all, let's define it. So what is indirect measurement? It's defined, and this is right at the top of your foldable, defined as the process of using similar shapes and proportions. So you're using the similar shapes and then you're writing proportions to find a measurement. And we've already done that. You guys, we've already been looking at relationships between triangles, rectangles, trapezoids in order to find missing measurements. So what we're talking about today is indirect measurement. It's another type of practical problem that we can solve using proportions. So indirect measurement can be used to find the measurement of objects that are too difficult to directly measure, such as the height of a building or a tree. And just like we talked about before I started the video, when you have something really tall, you'd have to climb it or get a really tall ladder to measure it, or you could just measure its shadow in relationship to something shorter in its shadow. So we're going to do a couple of examples, just 2 examples today, and then you guys are going to do some practice. So if you go to the bottom of the sheet, you have example 1. Now example 1 is just a picture of 2 triangles. And what I did here is I just cut mine into 2 so that you guys could see it easier. You have one long strip for example 1, but I just put it into 2 so it would all show up. So if you notice those 2 triangles there, it tells us that they're similar. We have our symbol for similar. So triangle ABC is similar to triangle LMN, and we're going to find the unknown measure of the angle. So what we're going to do for these, just like we practiced yesterday, is we are going to look at the corresponding sides. So what I'm trying to find out is x. So what I want you to do is to go ahead and take a color and then draw on the line that has x. Now LN is x. This is side length LN. That's x. So I'm going to find out which side length goes with x. So I'm going to look at the picture as well as the letters. LN goes with AC. Okay? And it looks pretty, it's pretty obvious from the picture too. It's that long side length, the diagonal side length of both shapes. So those 2 go together. And now in order to get x, I need to look for the relationship for 2 other corresponding sides. So what other 2 corresponding, what are one side from each triangle that I can use to compare? What is it? NM, okay. So I can look at NM, and then I'm going to find the corresponding side on the smaller triangle that goes with NM, and I'm going to look here, NM would be CB. So those 2 correspond as well. Now you notice we have a third side. Do I need to do anything with the third side? I don't. I could have picked the third side of each instead, but I chose the 42 and the 12, so I don't really need to do anything else with those numbers, because to form a proportion you need 3 numbers and then a variable when we're trying to solve a proportion. Okay? So we're looking at the corresponding sides. So AB goes with, let's see, LM. And BC, we already know, BC goes with MN. And then AC, which is the one that contains the variable or the corresponding side, AC goes with LM. No. AC goes with LN. Okay, So just a review of the corresponding sides. But we're not using them all. We're using AC and BC. Now, once I have this, I can write my proportion. So the side length of AB, which we're not going to use. So what I want you guys to do, I think you have some room on your paper. Yeah. Let's use different ones. Let's go ahead and put an X through that because that's not the ones that we chose to look at. So instead, I'm going to look at the one with the variable, right? So X is right here. That's LN of the larger triangle. Goes with what on the smaller one? 15. You could put it across or you could put it up and down. Either way, you're going to get the correct answer. So X corresponds with 15. And since I started with the large triangle, I'm going to start with the large triangle on the left side. So I'm going to start with 42. And 42 goes with what? What does 42 go with? 12. And this one was a little tricky because not only was it flipped, the triangle was flipped. Do you know what else was done to it? It was turned. It was rotated. So it's important that you guys look at the letters that are given in order to figure this out. So I'm going to just down here solve it. X over 15 equals 42 over 12. For this one, I would use my cross products. I could look at the scale factor, which is the relationship between the numbers going across. But instead, I'm going to take 15 times 42. And if I multiply those together, what do I get? Who's got a calculator? And then I'm going to divide it by 12, right? So 42 times 15. Giovanni, what'd you get? 200 for 15 times 42. 42 times 15. 630. So that's my cross product. And that's equal to 12x. And then I'm going to divide both sides by 12. Oh no, this is not good. Yeah, 630. So if I divide those, you get x equals what? 5.25? 525? 630 divided by 12? 52.5. So my answer is 52.5. 52.5. Okay. So it's centimeters. So I'm going to write 52.5 centimeters is my answer. Sorry about the smart boards being weird. Okay. So there we go. Kind of. There we go. 52.5. Make sense? Okay, so if you guys take a look at the next example. Now the next example, you're given a tree and the shadow and a person and the shadow. So this is similar in that you're going to use what you learned about similar shapes, but now instead of just looking at the shape, you're actually going to be able to look at a real life type problem. Okay, so just like we said before, if I wanted to measure the height of this tree, all I need to do is look at the relationship between a person who I know their height. I can measure a person's height very easily in their shadow and compare that to the relationship for the tree versus its shadow. So here, the actual height over the length of the shadow. So the actual height, we've got two different things that we're talking about. I'm going to try to draw with my mouse because my Pens aren't working well. So we've got two things that we're comparing. We have, is that a boy? I think it's a boy. We have a boy. So he represents the smaller triangle. And then what's the other item that we're measuring? A tree. So it's important that you guys are labeling this, or you can easily mess up your proportion. So you've got the boy, his height, comparing that to his shadow, and you're going to write that as a proportion comparing the tree to the tree's shadow. So how tall is the boy? 6 feet. Okay, so I'm going to put the 6 over here. And what's the shadow of the boy? 8. Okay, and then do I know the actual height of the tree? You see that right here going across? No, so I'm going to use a variable. Do I know the shadow of the tree? It's 24. Okay, so you're comparing the boy and his shadow to the tree and its shadow. Questions on that? Make sense? So if you look at this too, you could actually make, let's see how good I'm going to be with this right now. You could actually make, trying to get a line, these into triangles. You see? So you could actually think of these as similar triangles where the height, you have the height of the objects and then you have the shadows. You just don't need that third side length. Does that make sense? If you connected those, you could actually make two similar triangles. All right, now the next piece is you have, get back to my pens, choose a different color. So here you have, it says identify the scale factor. So that's a word we haven't used a lot, scale factor. So for the scale factor, that's basically what you would multiply the boy's height and shadow by to get the tree's height and shadow. So for the scale factor, you would be looking for the relationship that's going across. So do you guys see the relationship between 8 and 24? What would you do to 8 to get 24? You'd multiply it by 3, right? So this is a times 3 relationship. So the scale factor is times 3. So the scale factor, so write that on your paper. And I'm going to attempt to do it with a mouse. Your scale factor is equal to 3 because the tree is 3 times the height of the boy. The tree's shadow is 3 times the height of the boy's shadow, or the length of the boy's shadow. So you can use either cross products, or you could also use scale factor to figure out your missing value for x. So how tall is the tree? 18. See what I did up here? I just used, instead of doing cross products, I used the scale factor, which is your horizontal relationship, to determine that x, which is the tree's height, is equal to 18 feet. Now if you chose to use the cross products, that would be okay too, because you'd multiply 6 by 24 and then you would divide that by 8, and that would also give you 18 feet. So on IXL, you guys are going to have problems that have not only similar shapes, but also problems that ask you to find the height of objects based on the relationship between other objects and their shadows. And that concludes our lesson on indirect measurement.